Welcome back to the channel, everyone. In today's video, we're going to focus on the key first layer printing features of 6 well-known 3D printers that all have auto-leveling, but is it the same? The BeagleCamera used in the video is made by Mintion. BeagleCamera is a 3D print camera. It currently provides the main remote monitoring function. You can check the printing progress and other situations in real time through the Beagle Print app or web page. You can also control it. At the same time, camera has the ability to automatically generate time-lapse videos. If you want to have BeagleCamera, you can buy the link in the video description. But before we get into comparisons, let's take a moment to discuss why the first layer in 3D printing is so important. Most prints fail. They happen because the all-important first layer is not adhering. Whether it's not sticking to the bed or warping, getting the first layer right is critical. Given that perfectly flat heat beds are very rare, adjusting the distance between the nozzle and the heat bed by changing the z-axis in real time during the printing process is critical for optimal adhesion as well as successful printing. Okay, laying the groundwork, let's start comparing these 6 3D printers, all of which are printing with PLA material in this video. Comparison of first layer printing results. This is BamBu P1P. Layer height of 0.2 mm slice print in BamBu Studio. The entire first layer shows excellent adhesion. Some minor issues were observed in the lower and upper left corners, where the filament could not overlap the surrounding filament due to the nozzle height. This is the Prusa I3 MarK3S Plus. Again, I'm using Prusa Slicer 2.6, selecting Prusa i3 MK3S plus MMU2S as I have MMU2S installed, then selecting 0.2 mm material and layer height, importing the first layer of the model, scaling to print the model at a non-locked scale, and then saving the file, uploading it via the BeagleCamera to upload the file and start printing. Result: the first layer is firmly bonded. Erasing reveals a more pronounced thickness, which reflects the flatness condition of the platform. This is the Ender3 S1, again using OrcaSlicer 1.6.3, selecting the printer, modifying the printer start code, adding the M420 S1 and uploading the file via BeagleCamera, then printing. The prints are poorly bonded, resulting in print failure. The model also shows adhesion issues and inconsistent thickness. After constant debugging and failures, mainly adjusting the compensation value of 16 points and the offset value, the print platform that it finally successfully adhered to was not perfect. There were still some areas where the nozzle and heat bed were not at the right distance and removing the model from the platform would be painful. This is Ender3 with BeagleTouch installed. I used Prusa Slicer 2.6 and then modified the printer star code to add the M420 S1, uploaded the file via BeagleCamera, and then started printing. Gaps between filaments were observed in some areas when the model was adhered to the platform, indicating an inconsistent distance from the nozzle to the bed. After constant debugging and failures, such as modifying the grid_max_points_x grid_max_points_y where the data collection points, from 6 by 636 points to 8 by 864 points, and finally 12 by 12 144 points, there were always similar results. I then used G29 bed leveling auto_bed_leveling_UBL and the results were excellent with only a slight visible overlap problem in the lower right corner. Learn about auto_bed_leveling_bilinear and auto_bed_leveling_UBL, unified bed leveling. One creates a bed mesh, a hot bed with a raised or depressed center, and the other creates a 3D topographic map, all hills and valleys. This is AnyCubic Vyper, using OrcaSlicer 1.6.3, selecting printer, modifying printer start code, adding G29. Upload files via BeagleCamera and start printing. The results are not perfect, but it is clear from this result that there are some areas of high and low nozzle and hot bed heights that can be observed, and this result is valuable in recognizing the impact of different nozzle and hot bed heights on printing. This is Artillery Sidewinder X2, I use Prusa Slicer 2.6, select Artillery Sidewinder X1 BeagleTouch configuration, upload the file via BeagleCamera and start printing. The model adhered well, but a wavy pattern was visible on one side, indicating an area where the nozzle was too close to the bed. Achieving the perfect first layer requires a combination of the right equipment, precise setup, and trial and error. While the Prusa and BamBu models show encouraging results right out of the box, others such as the Ender3 S1 and AnyCubic Vyper require some fine-tuning. Regardless of the printer, understanding its nuances and features can significantly improve print success. This comparative analysis can provide guidance for those in the market for a new 3D printer or looking to optimize their current setup. Remember, the journey to perfect printing begins with the first layer. That's all for this installment. Please let me know how you feel about the content of the video by commenting or using the "I like this" or "I dislike this" buttons, and if you haven't subscribed us yet, please consider subscribing. You can also check out our previous videos which I believe will be helpful as well. I hope you enjoy printing. I'm Kim, goodbye.